All right, let's talk about one of those things in Python that seems super simple, but can cause some really confusing bugs if you're not careful. We're talking about copying lists. Get this right, and your code will thank you for it. Let's jump in.
So, picture this. You've got a list of something, numbers, names, whatever, and you need to make a copy of it, maybe to mess around with it without changing the original. Sounds easy enough, doesn't it?
So your first instinct, and pretty much everyone's first instinct, is to just assign it to a new variable. A is our list, so we'll just say B equals A. Done, right? We've got our copy.
Okay, so now you go to work on your new copy, B. You add a new number to it, maybe change one of the existing values, but what's happening to your original list, A, while all this is going on?
And this is the moment where things can go sideways. That simple little equal sign doesn't actually do what you think it does. It's a classic trap, and it's behind some of the most frustrating bugs you'll ever encounter.
So let's really dig into this copying conundrum. We're going to see exactly how this one simple line of code can lead you down a very confusing path. Okay, let's watch it happen in real time. First, we've got our list, A. Then we make what we think is a copy, B. Now watch. We're going to add the number 4 to our copy, B.
Now think for a second. We only touched B, right? We appended to B. So our original list, A, should be completely untouched. That's the logical expectation.
But nope, look at that. When we print A, the number 4 is in there too. Both lists changed. And that is the core of the problem. Your original data, which you thought was safe, just got changed by accident. In a big program, that's a recipe for disaster.
So what on earth is actually going on here? Well, to get it, we need to understand a fundamental idea about how Python handles variables and objects. It's not magic, it's just a different way of thinking about it.
The key word here is mutable. It sounds complicated, but it just means changeable. You can add things to a list, remove them, change them. It's not set in stone. Think of it like a shopping list on a piece of paper. You can always add or cross things off. Because they're changeable, Python is very efficient with them.
And this slide right here is the whole story. When you say B equals A, you're not making a second list. You're just putting a second name tag on the exact same list. Imagine you have a box. You put a label on it that says A. Then you put another label on the same box that says B. If you reach in and change the contents using the B label, of course the box labeled A is also changed. It's the same box. What we actually want is a true copy, a second completely separate box. The great news is, once you see the problem, the solutions are actually really easy. Python gives us a few different tools to create that true independent copy. Let's look at 3 of the most common ways to get the job done right. First up is a classic, very Pythonic technique called slicing. The syntax might look a little quirky at first, but it's super powerful.
See that little colon inside the square brackets? That's the magic. It's a shorthand that tells Python, hey, I want you to go through the original list, element by element, and build me a brand new one from scratch. And just like that, you have 2 completely independent lists. Now if you change copy list, the original doesn't even notice. Problem solved.
Okay, our second option is maybe a bit more obvious just by reading it. You can use the built-in list function. This is great because it makes your code really easy to understand. You just pass your original list into the list function. Its job is to construct a new list. And here, it uses the elements from your original list to build it. Simple as that. And just like with slicing, what you get is a completely separate copy. If you start adding or removing things from new fruits, the original fruits list is perfectly safe. And finally, we have what is probably the clearest and most direct method of them all, the list's own .copy method. There is zero confusion about what this code is trying to do. You just call .copy right on the list object itself. This is often the preferred way in modern Python because it just reads like plain English. Hey, numbers, give me a copy of yourself. And the result is, once again, exactly what we want, a brand new list. You can go wild changing numbers copy, and numbers will stay exactly as it was. Okay, so we've seen the trap, we understand why it happens, and now we've got 3 solid ways to avoid it. Let's just wrap this all up into a few key points to remember. So here's the bottom line. That equal sign, it's just a new label for the same object. It does not make a copy. To create a true independent copy, you need to use one of your tools, slicing with // the list function, or the .copy method.
Getting this right is what keeps your data safe and your code predictable. So you're all set. You're ready to copy lists like a pro. But here's a little food for thought. All the methods we just talked about create what's called a shallow copy. So, what happens when the thing you're copying is a list that has another list inside of it? Well, that opens up a whole new can of worms, and it's a puzzle we'll save for another time.